Hi everyone. In this video, we are going to discuss about the field components. So in the previous video, we have derived 6 equations from Maxwell's equation. And from these 6 equations, we derived the field components, that is Hx, Hy, Ex, Ey. Now to derive, the field components are Hx equal to minus gamma upon h square dou hz upon dou x, and Ex equal to minus gamma upon h square dou Ez upon dou x. Hy equal to minus j omega epsilon upon h square dou Ez upon dou x. Ey equal to j omega mu upon h square dou hz upon dou x. So these equations are derived from the 6 equations, that is gamma Hy equal to j omega epsilon Ex, minus gamma Hx minus dou hz upon dou x equal to j omega epsilon Ey, dou Hy upon dou x equal to j omega epsilon Ez, gamma Ey equal to minus j omega mu Hx, minus gamma Ex minus dou Ez upon dou x equal to minus j omega mu Hy, and dou Ey upon dou x equal to minus j omega mu hz. Now to solve for Ex, we consider the equation gamma Hy equal to j omega epsilon Ex. From this, we will get Hy equal to j omega epsilon upon gamma into Ex. Now we consider the equation 5th. Now substituting the Hy in equation number 5. So equation 5 is minus gamma Ex minus dou by dou x of Ez equal to minus j omega mu Hy. That is minus gamma Ex minus dou Ez upon dou x equal to minus j omega mu into j omega epsilon upon gamma Ex. Now we will get minus gamma Ex minus dou Ez upon dou x equal to omega square mu epsilon upon gamma Ex. The terms containing Ex are taken to one side, that is, and also j square equal to minus 1. So minus 1 into minus 1, that is 1. So that is how we got omega square mu epsilon upon gamma into Ex. Now minus gamma Ex minus omega square mu epsilon upon gamma into Ex, which is equal to dou Ez upon dou x. Now multiplying it with minus 1, the equation becomes minus dou Ez upon dou x equal to omega square mu epsilon upon gamma Ex plus gamma Ex. That is minus dou Ez upon dou x equal to Ex into omega square mu epsilon upon gamma plus gamma. That is minus dou Ez upon dou x equal to Ex into omega square mu epsilon plus gamma square upon gamma. Here gamma square plus omega square mu epsilon is equal to h square. Now replacing this with h square, the equation becomes minus dou Ez upon dou x equal to Ex into h square upon gamma. Now we want the field component Ex. That is Ex equal to, that is Ex equal to minus dou Ez upon dou x into gamma upon h square. So Ex equal to minus gamma upon h square dou Ez upon dou x. So this is Ex. Now to solve for Ey, we consider the equation gamma Ey equal to minus j omega mu hx. Now we will get hx equal to minus gamma upon j omega mu into Ey. Now we consider the next equation, that is equation number 2, minus gamma hx minus dou hz upon dou x equal to j omega epsilon Ey. To solve Ey, we consider this equation because it contains the dou hz upon dou x and Ey depends on the field component hz. Now substituting hx in the equation number 2, that is minus gamma into minus gamma upon j omega mu into Ey minus dou hz upon dou x equal to j omega epsilon Ey. Gamma square upon j omega mu into Ey minus dou hz upon dou x, that is equal to j omega epsilon Ey. Taking the terms containing Ey to one side, that is gamma square upon j omega mu into Ey minus j omega epsilon into Ey equal to dou hz upon dou x. Now taking the common component, that is Ey outside, Ey into gamma square upon j omega mu minus j omega epsilon, which is equal to dou hz upon dou x. So Ey into gamma square plus omega square mu epsilon upon j omega mu, which is equal to dou hz upon dou x. Here h square equal to gamma square plus omega square mu epsilon. Now replacing this term by h square, we will get Ey into h square upon j omega mu, which is equal to dou hz upon dou x. Ey equal to j omega mu upon h square into dou hz upon dou x. So this is the field component Ey. Now to solve for hx and hy, it is really simple because we have found out the Ey and Ex, and from this we can find the hx and hy field components. For that, we consider the equation gamma Ey equal to minus j omega mu hx. Now the equation 4 becomes hx equal to minus gamma upon j omega mu into Ey. Substituting Ey in the above equation, that is Ey equal to j omega mu upon h square dou hz upon dou x, that is hx equal to minus gamma upon j omega mu into j omega mu upon h square into dou hz upon dou x. So cancelling the j omega mu component, hx equal to minus gamma upon h square dou hz upon dou x. So we have got the equation for the field component hx. Now to solve for hy, we consider the equation gamma hy equal to j omega epsilon ex. And we also consider the equation x equal to minus gamma upon h square dou ez upon dou x. So from equation number 1, hy equal to j omega epsilon upon gamma into ex. And we know ex equal to minus gamma upon h square dou ez upon dou x. So substituting ex in hy. So we will get, that is substituting ex in hy, we will get hy equal to j omega epsilon upon gamma into minus gamma upon h square into dou ez upon dou x. So hy equal to minus j omega epsilon upon h square into dou ez upon dou x. So we have got the 4 field components and we have derived these components from the 6 equations. Now we are discussing another fact, that is the field components always depends on Ez and Hz, and it can be divided into two, that is transverse electric wave and transverse magnetic wave. So for transverse electric wave, Ez equal to 0, that is Hz is a function of x and y coordinates, and in transverse magnetic wave, Hz will be 0 and Ez is a function of x and y coordinates. So in transverse electric wave, we have Ez equal to 0. So the components which depends on Ez will be automatically 0. That is hy equal to minus j omega epsilon upon h square into dou Ez upon dou x. And another component which depends on Ez is Ex equal to minus gamma upon h square into dou Ez upon, okay, that is dou Ez upon dou x. So hy is equal to 0 and Ex is equal to 0. Now for Tm, that is transverse magnetic wave, Hz equal to 0 and Ez is a function of x and y coordinates. So Hz is a component and Hx and Ey depends on Hz. So Hx equal to minus gamma upon h square dou Hz upon dou x, and another component is Ey, that is Ey equal to j omega mu upon h square into dou Hz upon dou x. So here Hx equal to 0 and Ey is also 0. And Hy is not equal to 0 and Ex is also not equal to 0. In transverse electric wave, Hx is not equal to 0 and Ey is also not equal to 0. In the next video, we will derive all the field components in the case of transverse electric wave, in which the field components Hy and Ex will be 0 and also we will derive all the field components for transverse magnetic wave in which Hx and Ey will be 0. I hope you all understood the concept, and if you have any doubts you can comment in the comment section. And thanks for watching this video. Hope you all liked it.